Hello everyone, welcome back to the channel. Today we are diving into Elastic Load Balancing in AWS, a powerful service that ensures your application stay available, scalable and resilient. This is going to be a two-part series and I have lined up some exciting hands-on demos towards the end. So make sure you stick around till the end of the video. Before we jump in, I did really appreciate it if you could subscribe to the channel. It helps me bring more DevOps and cloud content like this to all of you. Let's get started. First, let's understand what Elastic Load Balancing is. Imagine you are running a production grade online shopping application. Traffic to your app can spike during peak seasons or big sales and drop during quieter periods. To handle these fluctuations smoothly, your application needs to be elastic. It should scale automatically based on demand and also it should be highly available. That's where elastic load balancing comes in. ELB is mainly responsible for improving availability, ensuring fault tolerance, and supporting scalability. It automatically distributes incoming traffics across multiple healthy targets, such as EC2 instances spread across different availability zones. If one instance fails, ELB reroutes traffic to healthy ones, maintaining uninterrupted access. And when combined with autoscaling, ELB enables your infrastructure to grow or shrink based on load, ensuring consistent performance. Now I will explain this with a simple diagram. As you can see in the diagram, we have deployed an application load balancer in the US East 1 region. We have a target group for our load balancer. We have deployed our application in 3 EC2 instances. The EC2 instances are placed in each availability zones US East 1A, US East 1B, US East 1C. Now, when our users is trying to access our application, the traffic will first hit the application load balancer. Then the application load balancer will try to reroute the traffic to any one of the available instances inside our target group. By placing the EC2 instances in each availability zones, we are providing high availability for our application. Our application load balancer has a health check which will periodically monitor our EC2 instances running on different availability zones. If the health check fails, the application load balancer will mark the instances down and it will stop routing traffic to that instance. So now I will tell you how we can achieve high availability through this architecture. Let's imagine the EC2 instance running on US East 1A has faced some issue and it stopped. Now the application load balancer will sense and mark it as unhealthy target. So now we have two healthy targets in our target group. So now when the user try to access our application, the application load balancer will reroute the traffic to two healthy instances which are currently available in our target group. Hereby we achieve high availability and fault tolerance in our architecture. Now I will explain how we can achieve scalability in this architecture. Let's assume we are having a peak load and many users are trying to access our application and we want to introduce one more EC2 instance behind the load balancer. We can go to the AWS console and we can create a new EC2 instance and we can add it to our target group. Once that EC2 instance is added, we will have 4 EC2 instances behind our target group and the application load balancer will try to reroute the traffic to any one of the 4 EC2 instances which are available inside our target group. Thereby, we can achieve horizontal scalability. We can also achieve vertical scalability by changing the instance family or EBS volume size, etc. for our EC2 instances. Now we will again go to our slide and we'll continue our theory session. Now that we understand what elastic load balancing is, let's go over the different types of load balancers offered by AWS and the layers at which they operate. Application load balancer. It operates at layer 7, application layer. It is ideal for HTTP and HTTPS traffic. It supports features like host based and path based routing. It also supports WebSockets and integration with containers. Network load balancers. It works at layer 4. It's built for extremely high performance, low latency, and can handle millions of connections. It is suitable for TCP, UDP, and TLS traffic. Gateway load balancers. It operates at layer 3. It enables us to deploy and scale third-party virtual applications like firewalls, intrusion detection systems, and deep packet inspection tools. Classic load balancer. This is a legacy load balancer operating at both layers, layer 4 and layer 7. It provides basic load balancing for EC2 instances, but lacks the advanced features of newer load balancers. AWS recommends using ALB or NLB for most modern architectures. Each type serves a different use case, from simple web apps to high performance backend systems, and security appliances. Before we go further, let me quickly explain two key concepts that elastic load balancing supports: availability and scalability. Availability. Availability means making sure that your application is always accessible to users. For example, if one EC2 instance or even an entire availability zone goes down, your application should still be reachable. ELB ensures this by distributing traffic across multiple healthy instances and across multiple availability zones. Scalability. Scalability is the ability of your system to grow or shrink based on demand. There are two types of scalability: horizontal scalability. For example, going from 2 EC2 instances to 5. ELB works perfectly with this by distributing traffic across all available instances automatically. Vertical scalability. This involves increasing the power of your existing instances, like upgrading to a larger EC2 instance types, more CPU or more RAM. While this can help in some scenarios, horizontal scaling is generally preferred in cloud native architectures due to its flexibility and resilience. So ELB helps us build systems that are highly available and scalable, which are crucial for modern cloud applications. To make it easier to understand the key differences, here's a quick comparison table I have created. It highlights the type of load balancers, their operating layers, and the use case they are best suited for. We can see application load balancer operates at layer 7, network load balancer operates at layer 4, gateway load balancers operate at combination of layer 3 and layer 4, and classic load balancer operates at layer 4 and 7. I have also listed the protocols which are supported, and I also listed the targets which are supported, and I also mentioned the proxy behavior. You see all the load balancer supports proxy behavior except the gateway load balancer, and I also talked about supports SSL termination. All the load balancers support SSL termination except gateway load balancer, and I have also listed the use cases. For classic load balancer, the use case is legacy apps. For gateway load balancer, it is security appliances. For network load balancer, it is high performance apps. For application load balancer, it is web apps or microservices. And the reachability part, we can reach the application load balancer via virtual IP, and also the network load balancer we can reach via either virtual IP or static IP. And for gateway load balancers, we need route table entry. Now that we have covered the types of load balancer, let's dive into some of the key features of elastic load balancing that make it an essential part of any robust AWS architecture. Health checks. ELB regularly checks the health of your instances to ensure that traffic is only sent to healthy ones. If an instance fails, ELB automatically routes traffic to healthy instances, maintaining high availability. Sticky sessions, also known as session affinity. ELB allows you to bind a user session to a specific instance. This ensures that requests from the same user consistently directed to the same instance, which can be helpful for stateful applications. Operational monitoring and logging. ELB integrates with Amazon CloudWatch to provide detailed metrics about your load balancer's performance. You can monitor metrics like request count, latency, and error rates. It also supports access logs, allowing you to log all requests for auditing and troubleshooting. High availability. ELB is designed to be highly available, distributing traffic across multiple availability zones. This ensures that even if one zone goes down, traffic is automatically rerouted to healthy instances in other zones, reducing downtime. High throughput. ELB can handle millions of requests per second, ensuring that your application performs well under heavy traffic. It's built for scalability, allowing you to handle traffic spikes without performance degradation. Delete protection. To avoid accidental deletion of critical resources, ELB offers delete protection. This feature prevents the load balancer from being deleted until the protection is disabled, adding an extra layer of security. Now let's move on to how to actually implement elastic load balancing in our AWS environment. Alright, let's jump into the demo. I will walk you through setting up a load balancer in AWS and explain everything along the way. We will launch two EC2 instances and install simple web servers on them. Then we will set up both the classic load balancer and an application load balancer to distribute traffic between them. Now I will go into the EC2 console. I will click on launch instance. I will name the server as web server prod A. I will select the Ubuntu distribution. I will go with Ubuntu 22.04 for this demo. Instance type, I will choose T2 medium. The keeper, I will go with the keeper which I already have. If you want a new keeper, you can generate it using create new keeper. I have already mentioned the steps about how to create a keeper in my previous video on EC2. If you didn't have checked it out, please check it out. Network setting, I will leave it as default. I'll go to edit button, and if you see, I'm going with the default VPC. And subnet, I'm going to launch this instance in subnet A, US East 1A. Yeah. So this instance will be launched in US East 1A. Security group, we will create a new security group. I'll click on new create security group. I will name it as web server SG. So I will allow SSH and port 80. So we have added two rules. One is SSH, which allow us to SSH into our machine. I have put the source type as anywhere, which means anyone from internet can access it. And I have also included a rule for HTTP because we are going to deploy a web server. So if you want to access it over the internet, the instance should allow port 80, which means HTTP traffic. So I'm opening the port 80. So EBS, I will stick with 8 GB of GP2. So I'm going to launch the instance. So the instance is getting launched. We will wait until the instance is created. So I have created a Github page and I have created a small document. So this is the document I'm going to use for installing web server in the EC2 instances. I will put the link of this Github document in my video description. You can use it to install web server on the EC2. Now we will go to our EC2 section and see whether the instance has been created. We can see our instance has been created and it has been running. The status check is initializing. We will try to connect to our instance via instance connect and we will try to install the web server. Just click on connect. It will ask for the options. I'm going with the EC2 instance connect. Let's click on connect. We have now successfully logged into our machine via SSH. Now I will refer my GitHub document and I will try to install web server on this machine. First I'm going to update the apt repository. Then I'm going to install Git. Then I'm going to install Nginx. It will ask for yes or no. I will give yes. Now I will enable the Nginx to start at boot. So now we will try to access our web server over the internet. Let me grab the public IP address of the machine. So this is the public address. So I will go here. Since it's the HTTP one, paste the IP. I will hit the port 80. So as we see, our web server is up. We can see the welcome screen. Now we will again go back to the instance and we will try to deploy our own site into the web server. So I'm again going to the instance connect session and I will refer my document. So I'm going to clone a website repository. This is the command. Okay, we need to add git clone. I will change it in the document as well. Git clone. So now the repository has been cloned. So now we have to move the files from webapp/dist folder to where www.html folder to serve our own site. So I'll just use sudo and I will use copy. So I'm going to copy the content inside the dist folder to where www.html. Since we are copying the directory, we need to mention -r, otherwise the command will show error like that. So yeah, now we have copied. Let's go and check. So now we have copied the content and we are going to remove the default HTML file which is available, which is index.nginx.dbn.html. So I have removed it as well. So we need to use sudo for removal, sudo rm. Now it will remove. So now we have only one index.html. We are going to edit this index.html and we are going to mention our public IP address in the index.html so that we can identify from which machine our site is being served. So I'm going to VI the index.html and I will go to this line. Okay, and then I will go into the insert mode and I will remove this start bootstrap line and I will mention the public IP of the machine. This will help us to identify from which machine the website is being served, because in this demo we are going to have two web servers. So now I have modified the index.html. So now I will go and restart the Nginx so that the changes will be displayed on the site. So now we will try to go to the browser and try to open our site. See, we are getting our own site now. This is our site we deployed on our web server, and we can identify from which machine our website is being served. We can have the IP here. So this IP corresponds to the public IP of our web server prod A. So we have successfully deployed a web server A. So now I will go into the AWS console to launch our second EC2 instance and I will follow the same step to deploy the prod B machine. I will show you once the second machine has been deployed. I have completed creating the second machine web server prod B. I have followed the same steps which we have followed for web server prod A. I have followed the same documentation to install the web server. Only changes I done in web server prod B is I deployed it in a different availability zone. We have deployed the first machine is US East 1A. To demonstrate high availability, I deployed the second machine in US East 1B, and the index.html of the web server prod B will contain the public IP address of the machine, which is 34.235.170.38. So I have also tried to open the website in the internet. I can able to access it. This is the website for the machine B. From the IP address at the top, we can identify from which machine the site is served. So this site is served by 54.234.162.66. That is nothing but our prod A machine. On this site, for 34.235.170.38, it is being served by the second machine, which is web server prod B. So now we have deployed two EC2 instances and installed a web server on them, and we are able to access the site over the internet. So now we are going to deploy a load balancer. I will click on create load balancer. So there are four options available: application load balancer, network load balancer, gateway load balancer, and under the bottom we have classic load balancer previous generation. So first I will demonstrate how I can route the traffic using classic load balancer. I'll just click on create. I will name it as classic load balancer demo. So it will ask whether you want internet facing or internal. Internet facing means if we want our load balancer to receive traffic from internet, we will need to choose internet facing, or if we want our load balancer to serve only the internal traffic, we can give internal. This demo, I'm going to access the site over the internet, so I'm going to give internet facing. So it will ask for VPC. The VPC is same as where we launched our EC2 instances. Then it will ask for availability zones and subnets. As we seen that we have launched the EC2 instances in US East 1A and US East 1B. So I'm going to select the same so that our load balancer can route traffic to the instances in those two subnets. We can also add US East 1C, 1D, 1E, 1F as per our requirement. And then comes the security groups. The security group is security group for our load balancer. This will determine what kind of traffic will run through our load balancer. Since we are having a HTTP kind of traffic here, so we need to allow port 80 traffics to go into our load balancer. For our load balancer, I have created a new load balancer security group which will allow port 80 traffic inside our load balancer. So just use it, and correspondingly it will reroute the traffic. Here, if you know, our website is hosted on index.html. So I'm just going to give the ping path as index.html. So our health check will ping that index.html and it will see whether the site is coming. And if it is coming, it will mark it as a healthy instance. So we need to add the instances. We have two instances, web server prod A and web server prod B. We'll just confirm them both. And there are some attributes. This is something called cross zone load balancing. With cross zone load balancing, each load balancer node for your classic load balancer distribute request evenly across the registered instances in all enabled availability zone. And we have enabled connection training, and we also have a timeout, that is training interval. And if you want, we can tag our load balancer. For this demo, I'm not going to tag. So now we will go and create our load balancer. So it will show some error since we have given some space in the load balancer name. I'll just now go and remove the spaces. So now our load balancer will be created. We will wait until the load balancer is getting created. Our load balancer is created successfully. We can see status as 2 of 2 instances in service, and AWS will give us a DNS name using which we can access our load balancer, which will redirect our traffic to the applications behind it. So just take it. So now we can see our load balancer is serving as the traffic. So currently we are getting the site from machine ending with 66, that is our machine A. So I will again reload it. Now see, the traffic is being served by the machine B. So this is kind of a round robin. It will redistribute the traffic in a round robin way. So now I will go to into the AWS console and I will stop any one of the machine and I will show you how we can achieve high availability here. So now we have launched two machines here, right? So I'll just go and I will stop the machine A. So I'm just going to stop it. So now machine A is stopped. It's going to stopping state. We will wait until it has been stopped. So now the machine has been stopped, but we can still access the site because we have placed two EC2 instances behind our load balancer. Currently only one of our machine has been stopped. We are getting our site served from the another machine, that is ending with 38. So this is how we can achieve availability using our load balancer. We can also achieve scalability. We can spin up a new EC2 instance and we can install the web server on it and we can add it to our load balancer. We can see right here, we can see target instances. Here we can add our instances. We can have 3 instances. That can be a horizontal scalability. Suppose if you want to achieve vertical scalability, you can also do that as well. You can see that we have stopped the web server prod here, right? So You can go here, actions, and you can go to instance settings, and you can change the family of the instance, change instance type. So we have launched it as a T2 medium. We can change it to something else also. Currently I'm not going to do this in the demo, but I'm showing there is a scope for achieving vertical scalability also. So I will go and again start the instance. We will wait till the instance has been created. So now the instance has been running again. So if I go on it, so now we can see the load balancer is saving the traffic from both of the instances. So this is how you can deploy a classic load balancer in AWS. Now I will show you how you can deploy a application load balancer to serve traffic between two EC2 instances. So we will again go into the load balancer section. Before we deploy application load balancer, we need to create something called target groups. Application load balancer need a target group. So I will just go and create one. I'm going to the target group. I will just create a target group as it will ask us to choose a target type, either instances, IP addresses, Lambda functions, or application load balancer. For this demo, we are going with instances. So I just select instances. Target group name, I will give it as ALB demo TG. So here, since we are only trying to demo the web server, I'm going with HTTP 80 port, and VPC is same, and it will ask for protocol version. I'm going with HTTP 1, and LSEC protocol it will ask. So LSEC will be index.html. So I'm just going to next. Okay, here also we don't need to provide space. So now I will go on next. So it will ask for the instances. I will select our two instances. Then it will ask ports for the selected instances. In both the instances, we have deployed the web server at port 80. So I'm going port 80. So I'll just click include as pending below, and again go to the create target group. So now target group has been created successfully. So now I will go to the load balancer section and I will create a application load balancer. So this time we are going with application load balancer create. So I will just name as demo ALB. So it will also ask the same question, internet facing or internal. We are going with internet facing and IPv4 and default VPC. And since we have our machines in 1A and 1B, it's going with the same. And security group, I will just use a security group which we created for our load balancer, which is nothing but it will allow port 80 traffic to go into our load balancer without any issues. And listening, everything is same. Listener protocol is HTTP, and target group I will just give us ALB demo TG. And we have extra options to configure our load balancer to CloudFront and web application firewall. This will improve the security. And we can also use AWS Global Accelerated also. If you want, you can check and you can demo it. Each have its own benefit, which you can read. Now we will go and hit the create load balancer tab. So now our load balancer creation is in progress. You can see the status as provisioning. We will wait till it is created. Now our application load balancer has been created. You can see the status as active. Eventually it will take some 3 to 5 minutes. Application load balancer will take some time more than classic load balancer. For application load balancer also AWS will give us a DNS name. I will take the DNS and I will try to enter it into the web browser. So we are getting our website served. We can see our website is being served from both the instances. You can see the IP has been getting changed. So we have successfully deployed application load balancer and we have routed the traffic among two instances hosting the web server. And if you want to take a look at the load balancer security group, this is that I just enabled a port 80 inbound rule. This is the security group I have used on our load balancer. With this, our demo is coming to an end. We have created two instances and we have deployed web servers on them, and we have initially used a classic load balancer to route traffic among them, and we can see how it helps in scaling and availability also. And we have also created a application load balancer, and we have tried to route the traffic among the same two EC2 instances, and we are able to see the websites being served from two different EC2 instances. As like how we demonstrated scalability and availability for a classic load balancer, we can also do the same for ALB. The step is same. You can stop the one machine and you can try to hit the DNS name, and you can see traffic is being served from one available LT instance. And we can also do the vertical scaling also, and you can also do the horizontal scaling by creating one more machines and you can add it to the target group. I hope everyone liked this demo. With this, we have come to the end of our today's video. In the part 2, I will show how you can achieve path-based routing using Amazon Load Balancer, and I also will try to show demos for Network Load Balancer and Gateway Load Balancer. If you like this video, please share this video with your friends and connections. If you haven't subscribed to the channel yet, please subscribe. I will see you guys with another exciting DevOps content in my next video. Bye.